Bases, acids, or neutrals. Basic solutions contain very few hydrogen ions. Available.
Yeah, this is the rocket kit. Could we guess what? We've been to the mad science office.
Hydrogen ions.
What? Without that?
What makes basic
I don't think you're...
acid solutions contain particles called hydrogen ions.
You have to
Hydrogen
rocket
ions
in
are
your
what make acids
No,
corrosive.
there are no rockets.
Neutrals. Neutral solutions, the safest pH.
Oh,
Contain an equal amount of
Can you be quiet,
hydroxide ions.
thank you for reading
One
silently.
another
Okay, so what we're doing first is I'm going to demonstrate to you in visible fashion the topic we're studying. I'll tell you the topic. It is pH. Can you say pH?
pH.
Okay, so pH is our topic, and I've got 6 graduated cylinders, and I'm going to use these cylinders to show you how we measure pH scientifically. So goggles on.
Goggles on.
So my first chemical, I'm going to put a small amount into beaker number 1. And just take a look at it from where you're sitting. You can see that this liquid looks relatively familiar.
It looks like water.
Does it look like water?
Yeah, it's
little.
clear.
Okay, well, that is a good observation. I agree. It's a clear, colorless liquid.
That's kind of like water too.
Liquid number 2 is kind of. Do you think they're the number 1 and number 2 are the same?
Yeah.
Nope.
What?
Daggery says no.
Oh, one.
Gabriel
Can I
thinks
take
they
my
might be the
goggles
same.
off?
Number two. Number 2 doesn't have bubbles.
Oh, you saw less bubbles in number 2. Okay, that's a good observation.
And
That could be
it's kind of
important.
red.
Really?
And I can see small dots in it.
Okay, well, I think that might be a little bit of a figment of your imagination, or just what's behind the graduated cylinder. Okay.
This one is
Adding some chemical number 4.
kind of like water, except
Less clear.
less clear.
I love how children's imaginations are so vivid. So really, each of these 6 liquids is a clear, colorless liquid. However, only one of them is actually safe to drink, because one of them is water. But you would never know which one is water
Because they're all clear.
based on the way they look and mostly the way that they smell. Some colorless liquids may have a smell. One of these has a particularly strong odor, so you would be cautioned against
Can
it
we
if you
smell
smelled
them?
it. You may not. We're going to avoid smelling any of these chemicals on purpose because we don't want them to get into our lungs or our breathing. So we avoid smelling and tasting anything.
Why is yellow on your nose?
Yeah, that's a good question. It's not a problem. No, don't worry about it. So remember, when we're doing science, we don't touch our faces at all, and we avoid touching any of the chemicals unless we need to. And
Wait,
in your
can
case,
I see
you
all
don't need
these?
to. No, you may not see them. But
I'm
what
just
you are
looking at
going
the
to see.
labels.
No, you may not look at the labels. But what you are going to see
Where's the one with the
is you're
Y?
going to see me do a experimental
That would be
observation. I'm going to put these right in front like this. Set 'em. There we go. All right. So now everyone can see them. And what I'm going to do is I'm going to add one other chemical to each of these beakers. Now the chemical I'm adding is called a universal indicator.
It looks like paint.
It's not paint, but it is currently green. Now, this green universal indicator will actually cause the liquids to change color based on what is their pH. Can you say pH?
pH.
Okay, and I'll tell you about that in just a minute. but I'm going to add the
It's
color.
purple, not green.
So a chemical reaction just happened to change
That's
color.
red. That's red.
And that's the same type of chemical reaction, but the chemistry is different because of
That's
the chemicals
green.
in this colorless liquid.
It's blue.
So even though they looked like they were all the same colorless
Is this
liquid,
yellow?
Green. Is this yellow?
Which one's the yellow? They both
okay.
look
Yeah,
like
these end up
water.
about the same, and that's okay. That's what they're supposed to look like. So what we have are 6 different colorless liquids that have now become colored by adding a detector molecule. It's called a pH indicator, and what it does is it's like a chemical dye molecule, except it changes color.
Yellow.
Be quiet. It changes color based on how many
Put your goggles down.
hydrogen ions. Gabriel, Henri, put your goggles down. All the way over your eyes. Depending on how many hydrogen ions are in the liquid. So, can you say hydrogen?
Hydrogen.
Good.
Hydrogen.
Hydrogen.
Okay, and Henri, I know your name starts with an H, but so does hydrogen. H is for hydrogen. Hydrogen is the first chemical element on the periodic table of the elements. It's the smallest one, and it's the one that has it has a single positive charge, a proton.
hurt my ears.
So because it's positively charged, it affects the chemistry of these mixtures, and it makes the pH. If we have more hydrogen ions, the pH becomes pink. The color is pink. This has more hydrogen ions. If it has less hydrogen activity, it will be a more neutral yellow.
Which one's yellow? Which one's yellow?
These are both yellow.
Why do yellows?
They're pretty neutral. So these are normal or balanced. And then if we have a lot of hydroxide or base, this would be something that's in cleaners. This is the strongest one. This is purple. But then we also have green and blue as basic indicators. So how do we know that it's basic? Because we have a pH scale. The pH scale tells us how much hydrogen ions we have based on what color the indicator is. So this is kind of like a temperature scale, except this is this tells us what level of acidity we have instead of what level of heat we have.
There's 400. There's 100?
No, 14
So
at the
that's
top
a
and
strong
0
acid.
at the bottom. So if we have a lower number, we have more hydrogen ions. If we have a higher number, we have less hydrogen ions.
And so this is a strong acid,
That's right, strong acid,
and that's a strong base,
strong base.
and that's a base.
Yep, blue, purple, and green are all bases.
Yellows are acids.
Yellow or light green, and then orange and pink, and that becomes an acid. Good.
What else is there? Is there something other to do?
And just to give you some quick chemistry lesson here, what we have is H2O. Who can tell me what H2O is?
H2O.
Something that you drink all the time.
Water.
Water. H2O is water. Very good. H2O means that we have 2 hydrogens and 1 oxygen.
H2O. Wait, so H2O.
HOH or H2O. That's right. Now, what happens with water or H2O is it will separate into H ions and OH ions. So we get what's called hydrogen and hydroxide. Hydroxide makes a solution basic. Basic.
That's basic.
Hydrogen, H, makes a solution acidic. So all this is water being broken apart into its different pieces, and that causes more acid or more base.
Can break.
So we can mix these
Yep,
and
water
we can
can
make
separate.
it water.
Whoa, I didn't know that.
Well, it would not make, there would be more water in the solution, yes, but it would still have chemical in it, and it would
Can we
create a
mix
reaction. We're not going to mix these. We don't want to do a chemical reaction with these. But what I am going to do is carefully set them away in the bucket so that we can do some other mixing experiments. And the first thing we're going to do is we're actually going to use a different type of pH indicator. I had to clean that one out because I put it in the wrong well, because these labels are. Okay, so we're going to put just a little bit of chemical in each one of these, and then you're actually going to get to make some observations and record what you see.
Through your
Get
goggles.
my pencil.
Why do we need a pencil?
Because you're going to make a recording on your sheet there. We'll have Diggory do the writing for the group.
Can I do it?
No.
I didn't get to do it one. We haven't done this.
All right. So as you see, there are 6 different pictures and the chemical names next to each of them. So what we have is the chemical A is ammonia, chemical B is acetic acid, C is calcium chloride, D is sodium borate, E is polyvinyl alcohol, and F is water. So all you're going to do
water.
If it's water, now you know which one's water.
is I'm going to have Diggory do the first one as a demonstration.
6 is 6.
Mix it.
The
He's
water.
not going to
Is
mix
6
anything.
the water?
Like
What Diggory's going to do is he's going to very carefully touch the end of this pH strip to the letter A chemical. And when he touches it in there, he's going to pick it back up and he's going to look at what color it is. And he's going to set it on this paper towel and write
So-
down what he sees.
the one with the 1. This one.
Yep.
6 is the water.
Go. What color do you
6
see?
is water.
Blue.
It's blue.
Bluish.
Good. And now you're going to look at this indicator card to determine which.
Strong base.
Okay, and what's the pH number associated with that color?
10.0.
Okay, so now that's what you're going to record. You're going to write the color that you saw and the pH measurement that the color is associated with. You're going to write it right next to letter A there.
I need to be.
So strong base.
You can go P. Yep. Write the color, write the number, and you can also write strong base if you want. There's not a lot of room.
Then it's Gabriel, that's Dawn, then it's mine.
And then did you see how Diggory did that, Gabriel?
Yeah.
Okay, so what I want you to do is carefully take this strip, you're going to hold it by this end, and you're going to very carefully touch the other end to chemical number 2 or letter B, and lift it up, and look at the color, and see which color on this chart it matches closest. Okay, and what is that, what color is that? Put it on the paper towel now. Put it on the paper towel now. It's orange, which means what is it, Diggory?
Strong acid.
And what's the pH number,
I could
Gabriel?
read that.
What's the pH number, Gabriel?
40.
4.0. Good.
6 is water. Water.
Hey, hands up.
Right?
So B.
Acidic.
Yes.
Oh,
So record your observations. It's for safety. Keep your goggles on. Okay, so everybody, or Gabriel, can you remind me what chemical element we're measuring right now?
Now it's my turn.
It's called, what is this called again?
Turn.
Nope, that says acetic.
Acetic acid.
Yep.
Acetic.
Okay, now you're going to dip it in number 3, Liliana. Just the end. Just touch it. And then lift it up. And then see which color does it match.
It's yellow. It's yellow.
Okay, it's yellow. Record the yellow. And which number's by the yellow, Liliana?
6.
Good. Okay, so Degree's going to write that for you. Because that's where it would be stored.
It's yellow.
Okay. Yep, you're gonna do this one now. So carefully touch the end of this, and then dab it right into that liquid and lift it up. Okay. And which color is that, Henri? Show me which color. Show me. Which color is it?
Which green?
Very good. It's a very good green. Okay, here let's put that up here. Very good green. Okay. So green is a weak base and it's pH 8.0. You're still writing the
You
yellow.
got a weak one. Weak.
Well, it's better than having a strong base because strong bases are
Did I get a weak one, Papa?
more dangerous. You did. Yep, a nice weak base. No, you don't.
Did I get a strong one?
And we've got 2 more that over time the strong base gets weakened just by sitting out in air, so the color changes and it fades.
Wow.
So you got to record it right away. Yeah, so let's see. We'll have Gabriel measure number 5. That's this one.
Yellow.
Yellow. Okay,
Yeah.
good. Put it on the paper towel.
Now it's my turn.
And then we're gonna have Liliana and Henri hold this one together. And you're gonna dip it into, hold it together, both of you together. And you're gonna touch it into, hold one end together. And touch it into number 6 there. There.
That's too much. It was
Okay. And what color is it?
yellow. We put too much in it.
Yellow. Okay. Record it.
Where's that orange?
Okay.
Yeah. Next, what are we gonna do? What are
Baba
those
Next is
black
yellow.
goggles.
things for?
Baba have black
What are those things on the tray for?
Yep, I will get to the pipettes in just a minute. Because we've got another experiment that we're going to do with that.
Pipette. Pipette. Pipette.
Stop it, Hoovy.
Don't play with the tray.
Stop with the tray.
Stop
Okay,
with
good.
the
All right, so all of your results are recorded.
Yep.
Okay, good job. So you've got acids and you've got bases. Here, why don't you go ahead and write next to it, write an A if it's an acid and a B if it's a base. Take a moment to do that.
Blue.
Okay, and then I've got, I'm going to prepare a tray here and I'm going to put 4 cups on it. I've got 2 cups labeled number 1. They're going to get, it's not actually the first chemical that we use today, but I'm going to put in acetic acid in number 1, and I'm going to put our sodium borate in number 2. And those are the 2 chemicals we're going to use for this next set of experiments. So I'm going to just put a little bit of acetic acid in here. And acetic acid is vinegar. And vinegar is made of acetic acid diluted in water. And we're going to do 2 things with acetic acid.
He has apple cider vinegar on his fingers, so
He
it's
has.
made with the same thing.
Well, sort of. Apple cider vinegar is different than
Made with
regular
apple?
distilled vinegar.
It's
Then
made
I'm
with
going to
apples
add
sometimes.
sodium borate to number 2. Sodium borate is slightly basic.
So what is it? I've been writing stuff.
That's a
So it's a
lot.
little bit diluted.
That's a lot.
Alright, so I'm going to demonstrate the proper pipetting technique. So I'm going to put this pipette into number 1. And I'm only, so I'm going to squeeze the tip of the bulb. And I'm going to put it into number 1. And then I'm going to let go of the bulb and it's going to drop some of the liquid. And then I'm going to put some of number 1 into the other number 1. But I'm not going to touch the liquid that I'm delivering to because I don't want to contaminate my pipette. So I'm going to deliver the pipette into number 1. And then I'm going to put my pipette back into the original vessel. There we go. Same thing with number 2. When I drop number 2, I'm going to use the pipette and I'm going to deliver it like this. Now the reason I demonstrate that is because we're going to put some of chemical number 1 and some of chemical number 2 into our mystery liquid. And I have to go and fill up our mystery liquid because I ran out in the bottle.
It's water. It's water, yeah.
So we
It's
don't-
water! It's water.
So we don't know what our mystery liquid is, but we can determine what its pH is because I'm going to use the universal indicator again.
It's green. It's bean. Green. Bean.
There we go. So we have a green indicated solution, and based on our pH chart, we know that a green solution is neutral to maybe slightly basic, maybe an 8 pH. So we've got about a pH 8 right now. So the goal of this next experiment is to modify the pH of the mixture by slowly adding some of number 1 and some of number 2 a little bit at a time. But before we do that,
Hey, stop.
we're going to start a second experiment with the other number 1. I have with me a clay ball. I want you to take just a little bit, like this much, and turn it into a little pea-sized ball. And we're going to put our little pea-sized ball right inside the other cup of chemical 1, the acetic acid vinegar. Yep, and make it into a little ball, and then drop it on in there. Good.
Are you done, baby?
Perfect. Drop it in. Good. Okay, we're going to let that sit, and we'll look at that in a moment. So the first thing that I want you to do, Dagery, I want you to take some of chemical number 1, and I want you to drop it into our mystery liquid.
Can I try the next one?
Yes, you can do the second one.
Then you'll last because you was.
Okay, stop adding now. We've got a color change. So now, what pH do we have?
A strong acid.
We've now made our mystery liquid into a strong acid. We went from neutral, 8, all the way down to really, 1 or 2 in that range right there. Okay, so now Gabriel's going to use chemical number 2, and he's going to add a pipette, drop a pipette into the chemical number mystery liquid. Just drop it, drop the whole thing, but don't touch the liquid.
Whoa. It's Donnie.
There you go. And we might need to use a second one. I want you to get an extra squirt of this. So squeeze the bulb, and then put it into the liquid. Squeeze the bulb and don't let go. Squeeze it harder. Now put it in the liquid. Now let go of the bulb. Now it's drawn up. Now you're going to squeeze it out.
It was.
Okay, I want you to try it one more time. I'll let you add 3. Squeeze the bulb, draw it up. Let go of the bulb. Okay, then we're going to let Liliana do a few squirts. We've got a weak base here.
A weak base?
A weak base?
Well, this chemical number 2
That's
is a
good,
weak
that's good,
base.
that's good, that's good.
That's good, and now lift it up, and then don't touch it, just squeeze. Okay, and squeeze the bulb, squeeze the bulb, squeeze it. Okay, drop it, now let go of the bulb. There you go, and now bring it over and just squirt it in. Okay, one more time. Let go of the bulb. There you go, squirt it in. Okay, and then we're going to let Henri add some. Okay, so you're going to squeeze the bulb, suck up the liquid, lift it up, and squeeze it again.
Why do
There you go.
these have holes?
We're going to do one more so that you have air getting to your eyes. It's called ventilation.
Why do we need air getting to our eyes?
Ooh, it's changing.
It don't even
Okay,
want.
1, 2, 3. Okay, good job. All right, let go. Let go. Good. Okay, we have another color change.
Yellow! No, orange.
So we've got an orange now. Orange would put it at about a pH 3 or 4, maybe even 5 now. So we're going to bring it back to Daggery, and we're going to ask him to add more of chemical number 2. We're going to see how much more we can change the color. So you're going to have 3 squirts. Oh, 1. Oh, we can see a little bit of green. So it's maybe getting closer to 6 or 7 now. Okay, now we're even pushing to 7. 7, pretty solid, maybe even almost an 8. One more squirt. Ooh, good. All right, now put that back
Then
in.
will I do it again?
That looks good. That looks like it might be right at about 8
Then
back
will
where
I
it
do the
started.
1?
So, no, you're going to do 2 again. I want you to add 3 more squirts of number 2.
Whoa, the clay is weird.
Oh, we'll talk about that in just a minute. Add 3 more squirts of number 2. Let go of the bulb so it sucks it up. No, stop. I didn't say. There you go. And now squeeze it out. Okay, do another one.
Go.
Careful.
And another.
Squeeze it all the way out. There you go. One more.
Go.
Okay, good.
Kind of
So I'd
blue.
say we're getting pretty good basic. We might even be at about a pH 9 now. pH 9 on the pH scale here. So now, Liliana, you can decide. Do you want to see if you can add more 2, or do you want to add number 1 now?
Number 1.
Okay, you can add a squirt of number 1.
Let go. Okay.
There you go.
Bring it there. Don't touch it. Oh. Whoa, it made a bubble.
There you go. Okay, did we get a color change?
Getting kind of pink. Yeah, that's
It's getting pink.
again.
Not quite pink yet, but it's almost an orange.
It's kind of pink.
Okay, let's go back to 2.
No. We're going to let Henri add some now.
I had 3.
Well, we don't want to add too much of that one. So now you're going to add this one, Henri.
Then will I do the 1?
Don't
Let go.
squeeze this.
There you go.
Are my
Squeeze it.
cheeks yellow? Are why are my cheeks yellow?
There we go.
That's right, Trey.
And
Got
now
it.
we're yellow again.
I was in the middle of
some of number 2?
Can I add some
There
green?
you go.
Green.
Okay, now last one, Gabriel's going to add just a little bit more.
Last one is Gabriel. I wanted to do one.
It's already.
Okay, you can add number 1, and then we'll let you add number 2 again.
Then number 1. Then me.
Yeah.
I'm 2.
Okay.
1, 2.
Yeah.
Yay.
let go.
I'm 2.
You no, there's nothing in there.
And I can
Gabriel,
do.
squeeze it. Put it in the liquid. Let go. Now lift it up and squeeze it out.
Pink. Pink.
There you go. Now we're pink
Oh
again.
no.
Can I do one last squirt of this?
No, Liliana, add 2.
2.
Add number 2.
Then me.
Squeeze it in.
There's
already
already
stuff
liquid in here.
that.
Just squirt it in.
Diggory, calm down.
Okay,
Squirt it
this.
down.
There's already stuff in it.
Squirt it out.
That's a lot.
Okay, Henri, add another squirt of number 2. Now this one right here. There we go. Let go. Squeeze it.
Are we getting to the
Okay.
play one who beat that?
There we go. All right. So as you can see, the number 2 is not as strong as number 1 in changing the color back. And I don't even think we can get this to change all the way back.
That's a lot. Turning into a greenish
Okay, so
blue.
we've got a little bit of an orange color at the final here. And we'll just put it in there. There we go. And so you can see as I put that one back in there, it was a little bit more basic over here. So we're back to a more neutral or almost basic pH. And then what we can see with the clay balls is that we've mostly dissolved the clay. So we put clay, which is earthen dirt, in a acid.
Goggles, Henri.
Put your goggles on. In an acid, it's a vinegar. And vinegar eats away at the basic earth in material. So earth is also known as alkali. Clay is filled with all sorts of alkaline metals. And alkali is another term for basic.
Can I do something else now?
They're air holes.
That's doing a fire.
So I added vinegar to this
Fire
beaker.
again.
And now I'm going
Fire
to
again.
be quiet.
Candle and light it.
I'm going to light a candle in a beaker with vinegar at the bottom. And then I'm going to do a chemical reaction as a fire extinguisher, because many fire extinguishers work using chemical reactions. And this is the most basic chemical reaction that we can use to help extinguish a fire. What are 3 things that fire needs to burn?
Wood.
It needs something that will burn, fuel, wood or wicked candle. What else does it need?
Wood. A fuel and
Fuel.
oxygen.
Oxygen, it has to have oxygen to burn. And there's a third thing that you have to have in order to make fire.
A lighter.
An ignition source, something that will provide the necessary heat to make the fuel burn in the presence of oxygen.
What's that?
So,
Did we put your goggles on?
as I have a, be quiet please. As I have a fire burning, if I create a chemical reaction that will potentially get rid of one of those 3 key ingredients,
God, you have
then I can put out the fire.
You have God.
Be quiet. Are you listening? I'm going to create a chemical reaction that will eliminate one of those 3 ingredients that fire needs so that the fire goes out. So here we go. I'm going to add my sodium bicarbonate baking soda
Chemical
to make a
reaction.
chemical reaction. So which of those 3 essential ingredients did I just eliminate from the fire to put it out?
Oxygen.
Oxygen.
Oxygen,
Wood.
very good. What did I replace the oxygen with?
Gas.
A different gas. Yes, you could tell there's gas because what did you see in there, Henri?
Bubbles.
Liliana, very good. Bubbles in there. So when we create bubbles, we know we have a chemical reaction. This chemical reaction between sodium bicarbonate and acetic acid, vinegar and baking soda.
I have a question.
Quiet. The reaction between vinegar and baking soda has lots of carbons and hydrogens and oxygens.
Why didn't
Quiet. Quiet. Listen. It has lots of carbons and hydrogens and oxygens. So the reaction rearranges all of the carbons and hydrogens and oxygens so that we have lots of H2O, water, and lots of CO2, carbon dioxide. Everybody take a deep breath in and a deep breath out. Do you know what gas you just breathed out?
carbon dioxide?
Very good, carbon dioxide, which is not oxygen gas, and so if we have carbon dioxide, we can't burn a fire in that. So that's what I put in there instead of oxygen, is carbon dioxide. And carbon dioxide is a heavier gas than oxygen. So carbon dioxide floated out all of the oxygen, and the carbon dioxide stayed in. Okay, so that was the last experiment that we have to demonstrate. Any questions?
Why didn't the bubbles go all the way to the top?
Because there weren't enough chemical ingredients to make the reaction that big. Yes, Liliana.
So when bubbles are in food, that makes the chemical reaction.
Sometimes, more often, it would just be gases being released from heating or boiling might be happening, or it could just be air bubbles that got trapped inside your food or your beverage. But if you see soda, for instance, these carbon dioxide bubbles, that's what's inside soda. Bubbles, or bubbly water.
Me.
Yes, Henri.
Why do bubbles always go in your belly?
Yes, so if you get bubbles in your belly, whether it's through bread that's been cooked with yeast, so it has lots of carbon dioxide gas in it that was leavened, or if you drink soda, you get bubbles in your tummy, or even as you're eating, just air bubbles, you sometimes swallow them, and then you get gas in your tummy, and then you might do what? You might burp if you get gases in your belly. You could fart too, yeah. Usually the gases rise up.
Or boo.
Okay, any other questions at all?
No.
Okay, so what did we measure today?
Yay!
Avery, what did we measure today? Good, we measured the pH. And which chemical element does pH tell us how much of we have?
Me?
H is for... What is it, Gabriel? H is for...
Fine.
Stop it!
Stop
it!
What is it, Liliana?
Hydrogen.
Hydrogen. Yep, hydrogen. H is for hydrogen. So that's the chemical element we measured. That's our friend for pH. And we measured the pH scale, acids and bases. Yes, we're all done. You can take off your goggles and go wash your hands.